Okay, boys and girls, this is Module 5, Lesson 21. The objective of this lesson is to use visual models to add two fractions with related units using denominators 2, 3, 4, 5, 6, 8, 10, and 12. We will be using the tape diagram model, the number line diagram, and then we'll also do one where we don't use a model, but we do create equivalent fractions through multiplication of the denominator and numerator. So make sure you have your whiteboards out and are ready to write along with me. Good luck. All right, let's look at this problem. This is our application problem. I'm sorry it's kind of squished up in the corner here, but it'll give us plenty of work room. We have 2/5 of a liter of chemical A plus 7/10 of the chemical B make up chemical C. So we want to know how much chemical C there are. So let's draw this out in a tape diagram. First thing we're going to do is we know that we have 2/5 of chemical A, and we know that we have 7/10 of chemical B. And if we add all this up, this will equal chemical C, which we don't know the total. So let's make up our addition problem. I'll start with 2/5 plus 7/10. Well, in order to add this, we know that we're going to need a common denominator. And again, if we look at this, we want to figure out how can we change this 5 denominator to a 10. And we know that if we multiply 5 times 2, we would end up with 10. So let's convert that into a common denominator. So here we go. We're going to take 2/5 and we're going to multiply the top numerator and the denominator on the bottom by 2. And this would be 2 times 2 equals 4. 5 times 2 equals 10. Now we have that common denominator, and we can add up part A and part B. This is now an equivalent to part A, and of course we have part B here that did not have to be decomposed. We add that up, we'll end up with 11/10. Now we're not done yet, because if we look at 11/10, that I know out of 11/10 I can pull 10 tens out of there and end up with 1/10 left over. So we'll take 10 tens out, and that equals 1 and 1/10. And that would be the total for our answer of chemical C. All right, we're going to start with problem 1. Problem 1 is adding 3/8 plus 3/4. Because we, again, have different denominators, we need to find that common denominator. I went ahead and drew out a tape diagram, so I'd like you to pause your video and go ahead and draw this tape diagram. Once you've completed drawing the tape diagram and writing the equation, you can restart the video. Right, let's look at what we have right here. What we have now is we have our 3/8 right here. And we have 3/8 there. So that's our 3/8. Plus, we want to add 3/4. Well, if I go down here, I can count now the number of eighths in 3/4. It's 1, 2, 3, 4, 5, 6. So we have 6/8 is the equivalent to 3/4. Now we can simply add this up. 3 plus 6 equals 9, and then we're working in eighths. Now we have a problem. We know that we have a number bond here that we could create. We know that 8/8 and 1/8 would equal 9/8. 8/8 is the same as 1, and we have 1/8. So this would be our answer. Alright, boys and girls, I went ahead and drew this out ahead of time just to kind of clarify what's going on. So really what I'd like to do is kind of follow along at this point. If we noticed, our problem right here is 1/2 plus 7/8. So I knew that 7/8 is well over 1/2, almost 1. So I had to decide how big of a number line to draw. Well, I know 1/2 inch and 7/8 is going to be way over 1. So I went ahead and created a number line up to 2. So I drew 0, 1, and 2. My starting point is 1/2 inch right here. And then what I did is I divided my number line into eighths. 1/8, 2/8, 3, 4, 5, 6/8, 7/8, 8/8, and so on. And you can see that these are in eighths. So my starting point is 1/2 inch. Then I knew I had to add 7/8. So what I did was I went 1/8, 2/8, 3, 4/8, 5/8, 6/8, 7/8. And then what I could do is count. I knew this was my end point, and I could count back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my answer is 11/8. Well, I'm still not done because 11/8 is an improper fraction. So I used a number bond to split that 11/8 apart. 8/8 being 1, and then my leftover was 3/8. I added 1 plus 3/8 equals 1 and 3/8, which would be my answer right up here. So if I add that up, I end up with 1 3/8. This is our third and final problem in this lesson video. In this problem, we are going to be solving without using a model. So again, we're going to go back to that idea of creating a common denominator using list numbers. So what do both of these have in common? Well, they both can reach 8. We know that if we multiply 4 by 2, we will get to 8. So we're going to convert this 3/4 to eighths. So that's our first step. 3/4 times 2 equals, and remember, it's very important, whatever we do to the denominator, we have to do to the numerator when we multiply like this to create equivalent fractions. Our first fraction, then let's multiply this out, and we end up with 6/8 plus the 6/8 from right here equals 12/8. Again, if we go up to use that number bond, if we take this into a number bond, if I take 8/8 from here, that will equal 1, and we'll have a number bond left over with 4/8. So this equals 1 4/8. Now, some of you may say, we can write that up here, but then we're going to take it to the next step. Because some of you may recognize 4/8 as being the equivalent to 1/2. So we could, again, reduce that to 1.5. That was the end of Module 5, Lesson 21 video. As you remember, we used two different types of visual models. We used number lines, and we used tape diagrams, and then we also used multiplication of equivalent to create equivalent denominators and equal denominators. Again, if you have any questions, you can go back and rewatch the slides you need to, or you can ask me any questions. Now it's time to move on to the class kick problem set.